Why is the sky blue? Lord Rayleigh in the 19th century explained this. It is because of scattering of light by the gas molecules of nitrogen and oxygen. This scattering of light is a function of wavelength of light. According to Rayleigh, this scattering is inversely proportional to the fourth power of wavelength. But what is this wavelength? Imagine throwing a stone in a pond of water. This disturbance will create waves in water. These waves move up and down. The maximum upward and downward displacement of these waves are known as crest and trough respectively. Wavelength is the distance between two consecutive crest or trough. Physically, wavelength represents how short or long a wave actually is. There is another parameter of wave known as frequency, which tells us how often these waves are created. Frequency is inversely proportional to wavelength, which implies shorter waves have higher frequency and longer waves have lower frequency. The white light which we receive from the sun is a spectrum of 7 colors, namely violet, indigo, blue, green, yellow, orange and red. It is often known as Vibgyor. The wavelength increases as we move right. This means violet is the color that scatters the most, but a human eye is more sensitive to the color blue. That is why the sky appears to be blue. Wavelength of light not only tells about the scattering of light, but also about the energy that light carries. The expression for the energy that a photon carries was given by Max Planck and is E equals hc over lambda, where E represents energy, h represents Planck's constant, c equals speed of light and lambda equals wavelength. As from the expression, it is clear that shorter is the wavelength, higher is the energy. Thus, it was suspected that the energy of the photon should change during the scattering process. It was only 1 in 1 million photons that loses energy to the gas molecule and changes its wavelength. It was the Indian scientist C.V. Raman who observed this effect for the first time and won the Nobel Prize in 1930. He became the first Asian to win the prize in any branch of science. The scattering in which photons lose energy is called Raman or inelastic scattering. The change in energy during inelastic scattering causes the wavelength of photon to change, and this change is called as Raman shift. This acts as a fingerprint of the matter. Thus, by examining the change in wavelength, we can detect structure and composition of matter. Identifying materials, quality control, medical diagnosis, art conservation and environmental monitoring are some applications of Raman scattering. 28th February in India is celebrated to commemorate this discovery of the great scientist. Chandrasekhar Venkata Raman was born on November 7, 1888 in Tiruchirappalli, Tamil Nadu, India. Since childhood, he had deep interest in science. He graduated with a degree in physics from Presidency College in Madras. In 1917, Raman became professor at University of Calcutta. He made significant contributions in the field of optics, acoustics and molecular physics. In 1947, he established Raman Research Institute in Bangalore. On November 21, 1970, he passed away, leaving behind a legacy of scientific excellence and innovation that continues to inspire scientists and researchers around the world. So this was it for the video. See you in the next one and wish you a very happy National Science Day. Thank you for watching.